Okay, in the last video, we trained a model on a subset of data, aka allowing each estimator, so 100 estimators, to see 10,000 different data points rather than all 400,000 or so. And we saw a fairly big decrease in computing time, so our model trained faster. Now, what we might want to do is, because we can experiment a bit faster now, is try to find some ideal hyperparameters that are a bit better than what our random forest regressor defaults with. So let's have a look. And if you've had to think about it, you might have come across or thought of the idea of tuning, hyperparameter tuning with RandomizedSearchCV, something that we've looked at in a previous project and some other previous videos. So that's what we're going to have a look at. And so, if you're wondering what RandomizedSearchCV is, remember, we can always look up the docs, but what we'll do is, actually, maybe we'll just create a cell. Let's have a look at the code first. From sklearn, how would we import it? Model selection, RandomizedSearchCV, and remember, whatever machine learning model you're working with, you can always go insert the model name. So in our case, random forest regressor hyperparameter tuning. And this will give you some information on how to tune your random forest regressor or your random forest in general. So that's one way to do it. The other way is, from the way that we've seen, is RandomizedSearchCV. Oh, actually, let's be real here. There are many different ways to do it, but if you remember what RandomizedSearchCV does, if not, that's okay. RandomizedSearchCV. Go to the documentation. So randomized search on hyperparameters. Basically, we create a parameter distribution which kind of look like a dictionary. And RandomizedSearchCV is going to take our model, or estimator in scikit-learn terms, and search across this param distributions or dictionary for the best hyperparameters for our model. So that's what we're going to create. So different random forest regressor hyperparameters. And we'll go here, RF grid, nice and simple for the dictionary. This is the param distribution that I was talking about. And we might go over n estimators. Remember, if you're wondering where these came from, don't forget you can always search up here, random forest regressor hyperparameter tuning, and you'll find a fair bit of information on basically almost any machine learning model that you can think of different ways of how to tune the hyperparameters. Because again, this is not a perfect science. This is a whole bunch of trial and error of trying to figure out how things are going. And so what I'm doing here is I'm setting up a number of different values that RandomizedSearchCV is going to go through, try a certain number of calculations or combinations of them, and then figure out which ones achieve the best results, because that's what we're after, right? We're after a model that boosts us on the Kaggle leaderboard. That's what we're trying to do. With our default model with no tuned hyperparameters, we're sitting, and only 10,000 examples, mind you, that's the bigger one there. We're sitting at around 80th, so that's not bad. So what else are we tuning here? We've got number of estimators, max depth. These are all different parameters of the random forest. Min samples split, min samples leaf. And then we'll go max features. That's another good one. 0.5, 1, square root, auto. And then we also might go max samples. So we might also set this to 10,000 because we saw that before. Max samples increase how fast our model can find patterns in the data because it's only looking at 10,000 random examples rather than 400,000 that's in our training set. So in the spirit of trying to reduce the time between experiments, we'll set that to that. Instantiate RandomizedSearchCV model. We'll call this RS model, really creatively, RandomizedSearchCV, and we'll pass it a random forest regressor with n jobs equal -1 and also random state equal to 42 for consistency. Remember, that's similar to setting NP random seed. And then we're going to pass it our param distributions, which is RF grid, which is what we've just instantiated up here. And an iter, we usually do it for about 20 or so. Oh, well, I like to do it for about 20 or so for the first time, but we might change that. We might see why. CV equals 5, remember that's cross-validation. Verbose equals true. And the reason why we're gonna reduce this, we'll probably only do it, how much time do we have? Maybe only 2. Reason being is you might, oh, what has happened here? 2. Maybe that went really fast. I'm not sure why. We'll check that in a second, but that's all right. Maybe 5. 5's enough. Because I've already gone through this process, but I've set an iter to 100, but that took like 2.5 hours on my machine. So you could set this to whatever you want, whatever you have time for, but start low, because if we were to set this to 100, this cell might run for a couple of hours, and say if we were going home, we might set this to run for 100 and run overnight or something like that. Or if we had a lunch break, we might set it to run over a lunch break. That's what I used to do when I was working at a technology company in my city. I would run models over my lunch break and while I was eating food, and the computer was just calculating away. In our case, we're just going to set this to 5. And what we'll do, oh, that's why it ran so long, because we didn't even fit it. That's why this time is so small. rsmodel.fit. So what this is going to do, actually 2's enough then, because I thought this confused me, but I realized we didn't fit anything. That's why it went so fast. So this is what we can do. We go fit the randomized search CV model. What this is going to do, it's going to fit 2 iterations. So randomized search CV is going to pick 2 different combinations of parameters from here, assign them to our random forest regressor, and then fit it to the training data. And remember, it's only on 10,000 samples for the maximum. And it's going to tell us, well, we'll be able to find out in a second which are the best parameters. So because we're doing 2 iterations and we're doing a CV value of 5, there's still going to be 10 different fits. So this may take a minute or so. So we might time travel again. And I know we said we can only time travel every so often, but we unlocked a superpower going through this project because we're doing so well. We'll time travel until this cell is done. And we're back. So that took my MacBook Pro just under 2 minutes, right, to try out 2 different iterations with 5-fold cross-validation across a bunch of different hyperparameters. And now, even though this took about 2 minutes, it's still far less than our original 7-minute model trial that we did right in a few videos ago, because we've set max samples to equal 10,000. And now, because we have a trained model with randomized search CV, we can find the best model hyperparameters that randomized search CV found for us. And remember, we've only set this to 2. So if you have more time or more compute power, you might set this to something like 100 and find the best parameters from that. But we're only doing 2 for this case. And we go here, rsmodel dot best params. It's going to tell us, okay, so this is what the best parameters that it's found. 90 estimators, min samples split 16, min samples leave, 10,000, max samples because that was only one value, max features auto, max depth 10. And now remember, these might not be the best model hyperparameters because we've only searched for 2 different combinations, but we're going to work with them for now. Evaluate the randomized search model. Show scores, our beautiful show scores function, we're going to pass it the RS model. Now we may or may not see an improvement here in our evaluation metrics that we've used before. Yeah, so we actually see that this has worsened. That's okay, right? Because, as I said, we've only tried 2 different combinations. And now, in a past notebook, in a past project, when I was setting up for this project, I have actually, as I said, tried an iter equals 100. And I took a little break and I went and had some food because it took my computer just over 2 hours. And so we'll have a look at the best hyperparameters my computer found in 2 hours of searching, and we'll have a look at how they go in the next video.